Hey guys, today's topic is acceleration. Have you changed your velocity today? Well, maybe you did. Perhaps you were walking down the hall trying to get to your next class, and all of a sudden you hear the 1 minute bell, and you run or walk really fast so that you don't get kind of tardy. So at that point, you are changing your acceleration, you're changing your velocity. So in physics, an object with a change in velocity is accelerating. So acceleration is just the rate at which velocity changes with time. Changes in speed and or direction cause acceleration. So what does that really mean? So acceleration occurs when there's a change in either speed and direction or both. So for example, in this picture, the cyclist accelerates from rest and it increases his speed 2 meters per second every second. So here at 1 meter, he's going 2 meters per second. Okay. At 4 meters, he increases his velocity to 4 meters per second, and then finally increases for 9 meters at 6 meters per second. So he's accelerating. It's going faster each time. So as a result, the distance covered during each second is greater than the distance covered the previous second. So the shorter distance and larger distance and so on. So we as humans cannot detect velocities. For example, if you're driving in a car or a plane, you can't say, oh, you can't just say it feels to say that I'm going 10 miles an hour or 20 miles an hour. But you can sense acceleration. You can sense when you're have sudden changes in velocity. So for example, maybe in a car crash, or maybe you're accelerating, you could feel your movement going either faster or slower. The average acceleration of an object is a change in its velocity divided by the change in time. Remember that little triangle means change, and so this means that we're looking for velocity or time from final velocity minus initial velocity. Average acceleration is a vector, and it can be positive, negative, or zero. Remember, a vector has not only a magnitude or a number, it also has direction. Is it possible to be moving and have zero acceleration? Well, yes, you can move and have zero acceleration as long as your velocity is constant. And so an example of this would be if you're on cruise control in your car, so you're going the same velocity for a certain time, you're not accelerating at that point. If you're running at a constant speed on a treadmill, if you're going constantly at, you have a setting of 3 and you're going at 3 the entire time, you're going 3 miles an hour each time, you're constant, you're not accelerating. Now, if you start changing your speed from 3 to 4 to 5, then you're accelerating. But if it's the same, no, you're not. So the units of acceleration are meters per second squared. And that makes sense because we have velocity, which is meters per second, divided by seconds. So meters per second squared. So let's say, for example, that a Toyota Prius can go from 0 to 26.8 meters per second in 5.2 seconds. What is the acceleration of the car? So first of all, it goes from, so this is initial velocity, to 26.8. That's my final velocity. In 5.2 seconds, that's my time. So acceleration is a change in velocity over change in time. So my final minus initial divided by final minus initial time, but we only have one time, so it's 5.2. So when we do 26.8 divided by 5.2, we get 5.15 meters per second squared. Let's say, for example, we have a drag racer and it deploys a parachute and it slows down from 130 meters per second to 45 in 3 seconds. What is the acceleration of the car? Acceleration is change in velocity over change in time. So my final velocity, so it goes from to, so when it says from, that's my initial velocity, and my final velocity is 45. So 45 minus 130 divided by 3. And here we get a negative 28.3 meters per second. And the negative in acceleration means that it's we have deceleration. It's slowing down, and that makes sense because it goes from 130 meters per second down to 45 meters per second. So constant acceleration means that acceleration is the same at every instant in that time. So for example, sliding down a snow-covered hill gives you a steadily increase in velocity. And that's constant acceleration. So here's a graph depicting that same picture. So how would you find the acceleration of the object? So an easy way, now that we know, is to find the slope. So in a velocity time graph, the slope will give us the acceleration at that time. So let's say a truck moves as shown by the velocity time graph. Find the average acceleration of the truck for each period. Okay, so let's start with A. So in order to find acceleration with a velocity time graph, all I have to do is find the slope. So slope is rise over run. So at point A, my rise is 10. So 10 divided by 5, which is 2. So here at A is 2 meters per second squared. That's my acceleration. Now at B, we have constant velocity. So I'm going to write that down, constant velocity. So because we have a constant velocity, I know it's not going to have any acceleration. But if we want to show the calculation for this, we can say that it did not have any rise. It was started at 10. So there's nothing. 0. 0 divided by 10 seconds, because that's how far it went. From here to here at B, it went 10 seconds. So 0 divided by any number is going to be 0. 0 meters per second squared. Now at C, notice that my rise here is just 5 meters per second. Oops. 5 meters per second. Over my run, which is 10 seconds. Okay. But we notice that our slope here is moved down at C, so then I know that 5 over 10 is just 1/2 meters per second squared. Is going to be negative to show me that it's decelerating, that it's going from 10 meters per second down to 5 meters per second. And that's the acceleration, and acceleration should be squared. So describe the motion of the truck for the entire 25 seconds. So I would say at point A, it is steadily accelerating 2 meters per second squared. And then at B, it is still moving, but it's moving at a constant velocity, and that means that it has no acceleration. Finally, at C, it starts to slow down. It goes from 10 meters per second down to 5 meters per second. So at this point, it is decelerating, and that's why acceleration is negative 1/2.